Okay, so before we start talking about what is observability, I would like to give a quick introduction about myself. I'm a QA and a performance architect. I work for an MNC and I have about 15 years of ID experience. I also serve as a technical writer. I also do speaking events and also a researcher. Off late, I've been judging more hackathons, so I've done almost four hackathons. And I have also founded an association called American Association of IT Professionals. Um, so that's where we usually post all the contents which we are going to present, and also we have almost 1,400 people connected there. I would request you to go check it out and be part of it. So we are bringing a lot of industry standard professionals to do their sessions as well. So it's going to be much more interesting. So be part of it. Share your experience. I would really appreciate that. So that's being said, I think let's move ahead. So today's session is about observability. The idea of doing these sessions are more at the lightning pace. What do I mean by that is the sessions would be about 15 to 30 minutes time range. Our idea is to introduce you to a concept or introduce you to a buzzword which is going around so that you can start working towards it. So this is going to be a basic session. We're going to discuss what is observability. So I'm pretty sure in recent times, most of you would have heard at least the name observability, especially if you are part of performance testing and in engineering group specifically. This word would have come in front of you in one way or the other. So I think it's time to understand what is observability and to do a little bit of a deep dive. To start with, if I have to give you a basic definition of what it is, imagine if you are trying to draw a conclusion of a system based on the outputs it is generating. So, usually a system where it is having multiple layers, it will be generating a lot of logs and metrics and the details from his side. So, what you really have to conclude out of it, observe from it, and what actions you take is pretty much what the observability forms. The more specific textbook definition goes like its ability to measure systems' current state based on the data it generates, such as log metrics and traces. So you might be wondering, this is something you already do as part of monitoring. So why observability? So that's something we're going to address later in this session. So just to bring you back into what is observability, just think about that your system or an application is generating so much data each and every second, so much logs or transactions is going on. So your system will have so much metric to collect and show you. So how you make out of how you utilize those metrics to draw a conclusion, to take action. So that's exactly where the observability lies. So now that we know the definition of observability, let's understand why do we actually need it. Traditionally, we had a lot of applications where it was monolithic. What do I mean by that is you had on-prem infrastructure, you had a three-tier, four-tier infrastructure where you had a fixed database servers and the application servers were all fixed. And you were monitoring, trying to collect metric and analyze, troubleshoot only in those areas. So as we have progressed, the technology has improved. We are seeing in the last decade or so that the applications are moving more towards microservices and towards cloud, and now it's already moving into multi-cloud infrastructure. So we are moving into serverless computing, and we are moving into multiple nodes, multiple databases. So what it is really happening is, instead of you monitoring one specific component or a database, now you have plenty of them to monitor. Now you have more microservices. With Kubernetes, you have more pods. So what it is doing is increasing the complexity and layers which you have to monitor. So instead of monitoring one specific server, now you have to take care of multiple of them. Imagine if something goes bad in any one of those, one of the hundreds or one of the 20 servers you are monitoring. So how much more difficult it is going to be for you to get to the root cause of it, right? So now having so many moving parts, now you are having so many things to observe. The traditional monitoring or monitoring which you have been following will not be helpful. So, monitoring by itself has to evolve. So, that has given rise to a concept called observability. Observability is more like you're observing what is happening in your system and taking a proactive approach based on it. So, this is the reason why we need observability in first place. So now let's understand the difference between observability and monitoring. Because traditionally, whenever we had any tools in performance testing engineering, we always refer to them as a monitoring tools or a profiling tools. So monitoring tools like Grafana, where we actually go and check the existing infrastructure, and we always try to see how the CPU is behaving, how the memory is, what is the storage looks like, what are the thread pools. So that way to get an understanding of how the monitoring is. So monitoring basically works on an overview of your system. You can see on the left side there is a picture which depicts that. So monitoring is more of works based on alerting. So you have a CPU utilization of your server, you're monitoring. Let's say if it goes about threshold and you have an alert setup and you get an alert. So then you take an action, right? And apart from that, you're keeping a constant eye on how your system is behaving. That's more of an overview. So with so many microservices and infrastructure changes, how do you keep an eye on each of them? Or if there is any way to improvise and do more observing and doing things more proactively, uh, more reactively than traditional monitoring services. So let's say if you dig a little bit deeper and go into doing more debugging, profiling, dependencies analysis, and anticipate what is going to happen in the future, and then you take the action, right? That's where observability comes into picture. So whoever has been part of performance engineering, I you can relate to it really well, because testing we always try to give an outcome from performance standpoint, but when we talk about engineering, we always try to go multiple levels deeper. We troubleshoot, we do the deep dive analysis. That's where we actually go into the system logs, so the debugging, try to do the profiling of your system. Tools like Dynatrace, Splunk, Elastic APM will help you do profiling and exactly to pinpoint where the issue is, and having that conversation with your development team, right? That's more important. So let's see, when we compare these two, what are some major changes we have among them. So when we talk about monitoring, you're looking about more in terms of is my system is working or not. So that's where your monitoring lies. And when you talk about observability, you talking more in terms of what is my system doing. So that is going to be your viewpoint. In monitoring, it tells you when something went wrong or something goes wrong, it's going to give you an alert or show you a dashboard. But when it comes to observability, it is going to tell you why something is going wrong or what is causing that trigger to happen. Monitoring is more reactive in nature, and observability is more proactive in nature. I just observed that in the image it is flipped, but that's how it is. And in monitoring, it is helping you to do a quick response whenever something happens, an incident occurs. What in terms of observability, it is helping you to take some proactive decisions so that the duration it takes, the impact it has on your system is reduced, right? So if I have to really simplify things and pass on what observability and monitoring is, so imagine you're driving a car. If you only concentrate on your dashboard, or you see if there is any emergency light is coming out, or if maintenance light is coming out, so that's where you're actually observing. If you ignore everything else what is happening in your car, if you're hearing any noise, if something is broken, you could sense it. But if you're totally dependent on what is showing, the car is showing in front of you in the dashboard, that's where the monitoring is more aligned. You're trying to understand your car, how it is doing based on what you see in the dashboard. But observability is going beyond that. keeping an eye on how your brakes are doing, tires are doing, keeping a check on your oil and stuff like that. So what you're really trying to do is develop an understanding of your system or car in this case, where even before if the brakes goes out or a tire bursts, even before that you can take an action and minimize the impact and also minimize the time it takes. So you're doing much more beyond what it says, the system says, right? So that's how I can give you a comparison between these two. So let's move on. Observability again has some key principles. It has pillars, as we call. So it talks about three major things. One is metrics, logs, and traces. So if you talk about metrics, it's usually calculated. It's more what you see in the in your monitoring, where it is collection of values over a period of time, and it is trying to project that information in a more meaningful way based on the occurrence and time. So metric is could be a CPU utilization or a memory utilization. You have a metric to measure how your system is doing over a period of time. So that's going to be your metric. You analyze that. That is going to be one of the pillar. The next pillar is logs. So usually whenever an application is being used, it has plenty of logs to print. And most of the profiling and monitoring tools or any other tools uh, take this raw information in the form of logs and try to project a more meaningful or a graphical representation. So everything is pretty much based on the log. Either you have an active agents in the application which are collecting these data and projecting the graphs for you, or it can be fetched from the logs itself. So logs are at a very basic level. So any application which is being used, it could be structured or unstructured responses which are happening. Any event which is taking place inside the code, it's getting logged. So your observability has to go to the level of logs where you can actually go and analyze the logs and try to come up with areas which is causing the performance issues. And at last we have traces. Traces is an activity where you can actually run traces against a couple of requests, or you can make traces enabled and run your application to see much more in detailed. So what you're really trying to do is, instead of relying on logs which is coming for each and everything in your application, traces you can do for an individual request. So when the request is flowing through the entire application, starting from UI to the database or to downstream systems, however the system is flowing, it has a trail, it has its own what do I say, so it has its own logging system happening. So if you're more interested on trace doing a tracing for one specific request which is causing a lot of issues, then you do a traces and then you analyze it. That's how you will be able to see where exactly the more time is spent for that request and what is causing any performance issues, so that you can take a meaningful action, or you can come up with more meaningful fixes for it. So these are some key principles observability is based on. I would like to introduce you some tools. So these days, observability is catching up really fast, and if you have been into following recent conferences or any companies which make all these tools, they're catching up really big time on this, and all the major players are also into the observability category. So they already had all this information, could be scattered or showing in a different way. Now they have grouped them and form a new dimension altogether, and that is called observability. And some big players today, even if you want to go and utilize, is Dynatrace. New Relic is another company, another tool which has observability capabilities. Amazon AWS CloudWatch, App Dynamics, Splunk, Elastic APM Observability, and Datadog. So these are only few of them. There are much more than these. Pretty much any monitoring, even Grafana for that matter, even GitLab. So there are many of them who are already into observability. So this is going to be a new norm. As we go in future, you will see more and more companies adapting to it, and will be doing much more related to observability as a whole. So I would like to show a couple of dashboards so that you can get an idea of how the observability data looks like. So traditionally, as I was talking about monitoring only few components, here you can see the observability dashboard as much more elaborated, and it is giving you a overall sense of how your application is beyond a regular CPU memory or what's happening at the Java thread pool level. This is as you can see here, it's a database and services. Currently it's showing all as green, it's all fine, but it's form of a honeycomb approach they use. You can see a Docker imaging, how it is behaving so far, and you can see if you are using any UI and customer based, how the user experience is across the globe, right? And how many services do you have and how it is behaving over a period of time. You have an AWS account, you have a VMware, you have some web checks. If you have multiple hosts, how are they doing? So if you compare this to a traditional monitoring, you see this is much more specific. With this, you will be able to get a sense of how your application is behaving. And the more and more you understand, you spend time with observability dashboards, you will be able to master that as much. You can see there are one host which is causing problems. So if you go drill down, dig deeper, you will understand exactly what it is causing for. Let's say if that problem is occurring more frequently, then you can take a proactive approach and try to figure out why that issue is coming and how you can fix at the code level itself, right? Let me show you another dashboard, which is coming from Splunk, another big player. So you can see something similar, but it has a different set of metric. You can also see the current running processes. You will see how it is behaving, and when was the last run executed. It has a specific ID and what applications it's running against, and it has a progress trail by itself. And at the bottom, you can see some infrastructure, CPU usages, how it is happening at each level. You see some performance metric in last 24 hours, how many errors are coming in, 500 errors, 400 errors, and how is the latency happening, response time. And this is again the account management, customer login. So currently it's about, in the last 1 hour, 89% successfully handled. So it shows the password reset, invalid password. So it gives you much more in-depth information about your application, and also you can see some unique visitors. This is the high level moderators management, how many incidents are coming up, how many are resolved. So you're typically going beyond a regular metric or monitoring is what you do in observability. So imagine a situation where you're running a performance test or you're observing your application. You have a spike in your CPU. Let's say on an average it was using some 50%, 60%. Suddenly you spike for 95, 100%, and it goes back. So if you want to really know what happened at that level, there are two ways. One, either you go to your developer tech arc and say, hey, this is a spike in the CPU, and you don't have any more information. So with monitoring tools, that's what you're going with. So your application team would be good to know, but what do I do? Like then the dev team has to spend a lot of time analyzing, going back. There is a to and fro effort. But whereas in observability, what it is really enabling you is giving you an option to figure out what happens when the spike happened. Let's say you had a very high number of users coming in at a specific time, and or some process in your system suddenly spiked up. You know exactly, maybe because of a latest code drop, there is a vulnerability. So you pinpoint that and say this is exactly what happened at that time, and that is because of this process or this method or this query which is running. Then your developer tech team will really appreciate that, and then they can go and fix it right away. So that is the amount of information you will be able to give with observability. Whoever has used profiling tools, they might still think it's in the same zone, but observability is more than profiling. Profiling, where Dynatrace or Splunk, we are trying to always analyze the tracers logs. Still, again, we are more focused on a specific type of request. But observability is merging monitoring, profiling, and also adding more information to it. Right. So this dashboard serves really good to understand how your application is behaving over a period of time, and this can be used and shared with other stakeholders. They will also be appreciating how much your system performance is going on and how you can rectify it. Most of these tools do not have an open source option to use observability. There are a couple, so probably in future sessions we'll try to do exactly go little bit in deeper, understand why, how to set up and how to do the analysis of it. I hope this session was helpful. Again, the idea was to give you an overview, food for thought, and bring you into the concept so that you can work more on it. This is a LinkedIn handle of mine. I would really love to have a professional connection with you. Feel free to send a request, and also that's our company page.